Hello Year 5 and welcome to today's science lesson. Today we're going to be looking at something called gestation, which you might have heard, some of you might not have heard. So using these pictures as a clue, can you answer this question? What do you think gestation is? Now this is just a think at the moment because a lot of you might not know, but these pictures do give a clue. So just take a second to see if you can answer what you think gestation might be. Okay, let's find out together. So just as a starter for this lesson, there's another question here that I want you to think about. Guess or predict how long each of these animals is pregnant for. Now, what you will notice is that all 6 of these animals are what classification? Can you tell me? They are mammals. Well done if you said mammals. And gestation usually refers, if not all the time, refers to mammals. So it's something to do with mammals. So on your whiteboard or on a piece of paper, can you take a second, pause the video and tell me how long you think each of these animals might be pregnant for. It's not a test, it's just a quick fun activity, so don't worry if you're not sure, just have a guess. Pause the video now. Okay, here are the answers. So an elephant is pregnant for 630 days. That's almost 2 years. Whereas a mouse on the other end of this scale is only pregnant for 19 days. We are pregnant for 200, well, when I say we, humans are pregnant for 266 days, which, as most of you probably know, that's about 9 months, which means elephants are pregnant for more than double the time that humans are. Nearly 2 years for an elephant. And humans are actually 13 times longer than a mouse that they are pregnant. And then in the middle, we've got cats for 64 days, so still less than a human, 61 days for dogs, and 280 days for cows. Now, obviously, these are all general, and it's not exactly that number of days, but that is roughly how long each of these mammals is pregnant for. So some vocabulary that we're going to be thinking about today. So can you say the word after me? The first word is gestation. And gestation is the process and the period of time, that's the length of time between conception and the birth of offspring. In other words, how long a mammal is pregnant for is called the gestation period. It's how long an animal, a mammal in particular, is pregnant for. The next word is breeding. And breeding is the mating and production of offspring by animals. And then a word that I don't think you're going to need to repeat because I think you all know is elephant. And this is the mammal with the longest gestation period at 23 months. I think we might find an animal that's pregnant for even longer than an elephant, actually. We'll see. The next one is an animal you might not have heard of, which is the North American opossum. Can you say that? And this is the mammal with the world's shortest gestation period, even shorter than a mouse, and it's only pregnant for 12 days. And actually it gives birth to quite a few as well. And the last word is time period. Your turn. And this is the amount of time in which a cycle or task must be completed. So let's have a look at what gestation periods actually are. Read this top part with me. There are some signs to look out for when a female is pregnant. Her tummy will grow as the baby inside her gets bigger. The amount of time it takes for a baby to grow and be ready to be born is called a gestation period. And here's a bit more information. Before a mammal is even born, it grows and develops inside an egg or its mother. So this one does refer to animals other than mammals, but normally we only talk about gestation periods with mammals. This is called the gestation period. The gestation period, or the time when a mammal grows inside its mother, is different across species. For humans, the gestation period is about 40 weeks or 9 months. Why do you think it takes so long for a baby to grow and be ready for birth? I want you to pause and have a think about that question. So, this slide tells us a little bit more about the development of a baby inside the mummy's tummy or the womb. And at first it's called an embryo, and then later on it becomes known as a fetus. So this sort of shows between 1 month and 9 months the development the baby might go through. And because humans are so clever, we've developed ways of knowing exactly what's happening to that developing baby inside. So we know how quickly they grow. We know when they develop fingernails. We know when they develop hair and facial features. Did you know that babies, when they are 9 to 12 weeks inside the womb, they've already got their fingerprints? I think that's amazing. So we're going to find out how long it does take an elephant to get ready for birth. And if you remember from the beginning, we said it's about 23 months, which is almost 2 years. I think we looked at it in weeks at the beginning, but this is now in months. It's nearly 2 years, more than double a human's gestation period. We're going to carry on and think about why that might be. You might have written down on your whiteboards that elephants take so long to grow into babies because they are so big. And if you did say that, well done, you are correct. They are the largest land mammal, the largest mammal that lives on the land rather than in the sea, and have the biggest brains. Elephants are super intelligent. So it takes time for a baby to grow to their birth weight, which is about 230 pounds, about 30 times the weight of a newborn human baby. Wow, 30 times as big as a baby. That's a very cute baby elephant there, isn't it? However, there are animals that have an even longer gestation period than an elephant. Remember, we were mainly talking about mammals when it comes to gestation, but here we have a black alpine salamander. Now, can you guess what classification a salamander is? You might have said reptile, but actually a salamander is an amphibian. So this amphibian, which as you can see is nowhere near as big as an elephant, but it takes nearly 3 years to give birth. And a basking shark, which is a classification as a type of fish, takes 3.5 years. Imagine being pregnant for that long. And what about the species with the shortest gestation period? We did talk about it earlier. The shortest gestation period of any mammal that we know of at the moment is the North American opossum. Look how cute it is. Look at that face. And it only takes 12 days to give birth. That's less than 2 weeks. And amazingly, it gives birth between 16 and 20 babies. So less than 2 weeks to develop 16 to 20 babies inside its tummy. That's amazing. And of course, we have insects, and some of those have super quick gestation periods and lifespans. So here we have a mayfly, and they are born, reproduce and die all within 24 hours. They have 1 day and that's it. And you might see, if you go along into Hartum and by the rivers, you will quite often see lots of them flitting about, those mayflies. Okay, what I want you to do now, and we did think about this earlier with the elephant, but I want you to really have a think now about why some animals have longer gestation periods than others. So go back to what you wrote on your prediction, and I want you to have a really good think, and I'd like you to turn it into a sentence for me. Maybe you could start with I predict that, or I think that, or in my opinion, it could be that. So start a sentence with that and see if you can make a prediction as to why some animals have longer gestation periods than others. So pause the video now. Okay, I've got a little activity I'd like you to do now. This is on a Google slide and it's called Task 1 on the Google slide. There are 2 tasks, but this is just task 1. There are 2 slides for this. You'll find the slide that you can see here, and you'll also see this slide. And I'm going to play you a quick video that I recorded a minute ago that shows you what I want you to do. Now, just to warn you, I've put a little note up here to remind myself to say it, that in the video coming up, I'm going to say that the x-axis here goes up in tens, and I made a mistake there because, of course, the increments are not worth 10, they're worth 5. So when I say it goes up in tens, ignore me, they go up in 5s. You're going to create what's called a scatter graph, and a scatter graph is when you plot points and they sort of look like they've been scattered over the graph, but it actually shows you patterns that you might notice. So it's great for patterns, a scatter graph. So watch the video now where I show you what I want you to do. Hello Year 5, just going to show you the work that I want you to do here. So here we have a chart which shows you an animal, how long its gestation period is in weeks, and its weight. And on the next page of this Google slide, I've created a graph for you, and this is going to be what we call a scatter graph, which is where you're just going to plot different points using these blue circles that I've made for you up here. If one of the blue circles goes a bit wrong or you stretch it or something like that, don't worry, there's always the undo button, or you can copy and paste, or you can draw your own, so don't worry. So let's have a look first at the first page, and let's look at bear. And bear has a gestation period of 30 weeks and weighs 300 grams. So on my chart here, I'm going to take one of these blue dots. It's being a bit slow. There we go. And I'm going to find 30 weeks, which is here at the bottom. And then I'm going to move this up till I get to 300, which is there. Now it's going to be tricky to get it dead in the right place, but that's where bear is. Now let's find one that's not so easy. Let's have a look at, I'm going to go for chimpanzee, this third one, 32 weeks and 40 kilograms. So if I find another blue dot, now 30 is here, 32 will be just after it. And how many kilograms did I say it was? Kilograms, it was 40 kilograms. Right, this is the trouble, we're trying to remember them. So 32 weeks, and the first marker is 50 kilograms. So I'm just going to go just under it. So I'm just going to go just after the 30 and just under the 50. So it's going to be about there. So 30 and 50 is here, but it's 32 and 40. So it's going to be just after the 30 and just below the 50. So do have a look that your y-axis here goes up in 50s, your x-axis goes up in 10s. So some of them are not going to be dead on the lines. You're going to have to sort of go roughly where they would be. Okay, and that's what I want you to do for this first part of the activity. I am going to leave these two there for you. So the first one and the third one are already done, but you'll need to do the rest. Hello, Year 5. Okay, so I would like you to stop now, pause the video, do that task 1, only task 1. Don't go on to task 2 yet. And then once you've done that activity, come back and watch the next part of the video. Okay, hopefully your scatter graph should look a bit like this one. This is how I plotted it. Now, what's really interesting here, and we don't actually need to know the specific animals to look at this, but if you look, and this is what a scatter graph is good for, we've got what we call a trend here. We've got a large group that go almost in a diagonal line here. Can you see? And with a scatter graph, when you get into more advanced maths, you quite often draw what we call a line of best fit. And then you have a look at, obviously that should be a straight line, but I can't use a straight line on this. And you look at data that's on either side of that line. But of course we do have some anomalies here. This group here aren't really near that line. So if we just forget about the green group for a minute and just look at the rest of them that are near that red line, what can you work out from there? So remember, this x-axis is showing us the weight going up in, is showing us the gestation period going up in 5 weeks, not 10, like I said in the video. So they're going up in 5 weeks, but look, this y-axis is showing us the weight. So down here, we've got very, very light animals, just sort of 50 grams or just under 50 grams, with a very short gestation period. And up here, we've got very heavy animals with a very long gestation period. So I wonder what general statement we can make about these animals here. But it doesn't always work because of this group. Let's see if we can find out. So one factor that affects the gestation is the size of the animal, and that's what that graph, that red line on the graph, was showing us. So typically, and typically is an important word, we can also say generally, because it's not all the time, as that green group showed us. Typically, the smaller the animal, the quicker the gestation period. Can you say that last sentence with me, because it's really important? Typically, the smaller the animal, the quicker the gestation period. Think about the mouse versus the elephant. Mouse was very short, elephant was very long. But it's not true for all animals. There are other factors as well. So here's another one. Another factor for some animals, gestation occurs during restricted breeding season, which is when food is most abundant. So some animals only breed at certain times of the year. And they do that when there is more food around. They need the food for the energy during the gestation period to help the baby grow. So it can be, the length of time they're pregnant for can be to do with the amount of food. And that's how the animal has adapted to help the baby grow, to only be pregnant for while they have enough food to help them grow. Another factor, so this is factor number 3, another factor is the habitat or the environment. An animal which conceals, which means hides, its young underground or in nests will often have a quicker gestation period than a mammal which lives in the open. And that might be because they need to give birth quickly so they can get out and find food. Underground, there might not be as much food, so it hides in its nest underground, gives birth quite quickly, and then it can get out and find food while its baby is still safe underground. And this would obviously be for prey rather than for predators, so animals that are hunted by larger animals. Okay, we're going to have a think now. Why might understanding these gestation periods be important for zoologists? So why do scientists and zoologists need to know about gestation periods? Is there a link between how long an animal is pregnant for and how endangered it is? Think about maybe that last factor we looked at about being prey or rather than predator. So is there a link, do you think, between how long an animal is pregnant for and being endangered? I'm having a think also about animals like pandas who find it very difficult to become pregnant. They're quite endangered, aren't they? I think there might be a link there as well. Have a think now. We're going to finish by watching this video, and then there'll be another activity that I want you to do just to finish off the lesson. So I'll explain that activity in a minute, but we're going to just watch this expert video together first.
Hi, I'm Mike. We're talking about gestation periods. Now, a gestation period is the length of time from the fertilisation of the egg to the birth of the offspring, and it normally only refers to mammals. Now, gestation periods vary enormously between animals, mainly because some animals are really big and some animals are really small, and that has a big effect on the length of time that the youngster spends inside its mother's body. In humans, for instance, the gestation period is about 280 days. Now, in larger animals, such as the African elephant, this can stretch to 645 days, nearly 2 years, for the baby elephant to develop fully inside its mother before it's born. In many smaller animals, such as mice, gestation can only take 19 days. So you can see there's a huge difference between the two. Dogs and cats, for instance, take between 60 and 62 days for full gestation. Now you may think that the biggest animal would take the longest gestation period, like a whale, for instance. Well, actually a whale only has a gestation period of about 590 days, which, as you see, is less than an African elephant, even though its offspring, its baby, is much bigger than a baby elephant. There are some strange mammals though. Marsupials, for instance. A kangaroo is about the size of a deer, and a deer has a gestation period of about 200 days. But a kangaroo's gestation period is just over 40 days. And the reason for that is that a baby kangaroo is born more or less as a tiny embryo, and then it has to make its way from the birth canal up into the pouch of its mother, where it latches onto a teat and spends the rest of its time developing inside the pouch. So if you like, it's born early and then spends a lot of its time still growing inside its mother's pouch. And the North American opossum, another marsupial, does the same thing, but it's only inside its mother's body for about 12 days.
Okay, one final activity that I'd like you to do now, and this is on the last page of the Google slide, so you will need to go back to the Google slide to do this. You'll need to double click in these boxes, as always, to fill them in. And what I'd like you to do, firstly, is to explain what gestation is, so what we've been learning about this lesson. And then if you remember, there were 3 factors that affected the animal's gestation period. Do you remember? If you're not sure, you can go back and have a look. One of them was about the size of the animal, and that was what the scatter graph showed us. But there were 2 others as well. If you can't remember, just scroll back and have a look in the video, because we did talk about them there. Then it says explain about the shortest and the longest gestation periods you found about from your research. Well, your research has been watching this video. So in this video, we learnt about the longest gestation period for a mammal. But if you remember, there was an amphibian that had an even longer one. Maybe you could write about both of those, one for a mammal and one for an amphibian. And actually, there was a fish that was even longer, wasn't there? So maybe you can write about those. And the shortest, you've just heard Mike talking about in the video, was a type of marsupial. So can you remember that one as well? Scroll back in the video if you're not sure. And the last question was that one we asked just before the video. And this is a stretch yourself one, so this is a challenge, but I want you to have a go. Can you explain why understanding gestation periods is important for zoologists, that's the scientists that study animals, and when they study endangered animals? Why is it important to know about their gestation periods? Have a go at that last one. I'd love to know your ideas, and don't worry if you're not 100% sure, but I'd love to know what your ideas are. Okay, once you've done that second activity on the Google slide, you're done for today for your science lesson. So well done everybody, and I'm looking forward to seeing your answers when you turn them in.